Sure. Here is the deep, clear, and simple summary of everything big numbers and exponents. Words like teaching a beginner. Summary: understanding big numbers and exponents. 1. Big numbers are hard to read. Earth's mass is 5,970,000 kilograms. Uranus's mass is 86,800 kilograms. These numbers are too long and confusing to read, write, or compare. 2. What's the problem? Big numbers have too many zeros. They are hard to understand or remember. We need an easier way to write them. 3. What's the solution? Use exponents. Exponents are a short way to write repeated example. Instead of writing 10 times 10 times 10,000, we write it as 10 4. 4. What is an exponent? In 10 phonograph, 10 is called the base. 4 is the exponent. It means multiply 10 4 times. 5. How to read exponents. 10 is read as 10 raised to the power 4, or fourth power of 10, or 10 to the power of 4. 6. Examples of exponents. Number, exponent form. Read as read exponents. 100, 10 squared, 10 to the power 2, 1,000, 10 concrete, 10 to the power 3, 10,000, 10 chord, 10 to the power 4, 100,000, 10 fem, 10 to the power 5, 10 to the 10 6, 10 to the power 6. 7. Why are exponents useful? They help us write big numbers easily, read and understand them better, compare large values quickly, use them in science, space, and maths. Final simple definition. An exponent tells us how many times to multiply a number base by itself. Would you like a comic strip, table chart, or fun practice worksheet on exponents next? Absolutely. Here is a beautifully organized summary notes of all the key concepts we learned, written in simple language, perfect for quick revision and easy to remember like theory notes. Exponents and powers, key concepts. 1. Expanded form using powers of 10. A number can be split into parts using place values. Each place value is a power of 10. Example, 5, 6, 4 to 2 equals 5 times 1,000 equals 5 10 squared, 6 times 100 equals 6 times 10 squared, 4 times 10, 4 times 10, 10 1, 2 is 1 equals 2 times 10 0. Expanded form of 10 plus 6 10 squared plus 4 times 10 plus 2 10 10 3. 2. What is an exponent? Exponent is a short way to write repeated multiplication. It shows how many times to multiply the base number by itself. Example, 3 times 3 equals 3 4. Base equal 3, exponent 4, means multiply 3 4 times. 3. Exponential form. Writing a number using base and exponent is called exponential form. Example, 1,000 equals 10 times 10 is 10 equals 10. Exponential form, 10 goku. 4. Base and exponent, definitions. Term, meaning. Vefriki. Base, the number being multiplied repeatedly. Exponent, how many times to multiply the base? 10 can equals base, 3 equals exponent. 5 Fred, 5 equals base, 2 equals exponent. 5. Exponents for powers of 10, place values. Number, exponential form, means 10, 1, 10 shirred, ones, 10, 10, tens, 100, 10 squared, hundreds, 1,000, thousands, 10,000, 10,000s, 4 10,000s, 10 samp, lakhs, naverschnark 6. using other bases, not just 10. Any number can be used as base. Examples. Expression. Multiply as base exponent. Exponent. 2 equals 4. 2 times 2 times 2 times 2 equals 16. 2, 4, 3, 5. 3 times 3 times 3 times 3, 243. 3, 5 times 5 times 5 equals 125. 5, 3, 5. 7. Special name. Squared means exponent equals 2. Cubed means exponent equals 3. Examples. 4 squared equals 16, 4 squared. 5 3 equals 125, 5 cubed. 10 squared equals 100, 10 squared. 10 squared equals 1000, 10 cubed. 8. Powers of 1 and 0. Any number to the power 0 is 1, a 3 equals 1, where a equals 0. Any number to the power 1 is the number itself. A equals snakmkos. Examples. 5g equals 1 and is 10g equals 1. 7g equals 7, 2 3 equals 2. Easy memory tips. Easy memory tips. Exponent equals how many times. Base equals what number is being multiplied. 10 equals 1 always. Squared or power 2, cubed equals power 3. Expanded form uses 10 zeros, 10 fun, 10 squared to show place value. Remember this table. Number power of 10. Read as 10, 10, 10 to the power 1. 100, 10 squared, 10 squared. 1000, 10 ku. 10 cubed, 10,000, 10 score. 10 to the power 4, 1,000, 10 theme. 10 to the power 5. Final definition. An exponent tells us how many times to multiply a number called the base by itself. Exponential form equals base plus exponent. Makes big numbers easy to write, read, and compare. Would you like me to turn this into a printable revision sheet or create flashcards or a fun quiz to help you remember? Let me know. I'm here for fun. Absolutely. Here's a clean and easy to understand theory notes list, covering all the important concepts from what you just learned. These notes are made for quick revision, easy memory, and are written in the simplest language possible. Have theory notes. Exponents with negative numbers and variables. 1. Exponents can negative bases. You can use negative numbers as the base in an exponent. The sign of the result depends on whether the exponent is even or odd. Rule. If exponent is, then answer is even, positive plus odd, negatives. Examples. -2 equals 4, even exponent positive. -2 equals -8, odd exponent negative. 2. Variables as bases. You can use letters like a, b, extra instead of numbers. These letters are called variables. They stand for any number. You can raise them to powers just like numbers. Examples. 8a could read as a squared. A equals a qui read as a cubed. A to a equals a flat, a raised to power 4. 3. How to read powers. Power read as a quad, a squared, a cubed, a4, a to the power 4, a sit, a to the power 7. 4. Multiplying variables with powers. When variables are repeated in multiplication, we use exponents to write them shorter. Examples. A b equals a b b b b b b a b 4 a b b b a 4. 5. Power expressions with different order. Order does not matter in multiplication. Only the powers must be same to say two expressions are equal. Equal expressions. A quad b quad equals b quad add a minus a times b hence a times b equals a quad b quad. Not equal. A quad b a b squared. Because powers are different. 6. Expressing numbers as powers. You can write large numbers as powers of smaller numbers. Examples. 729 equals 3 sed, 128 equals 2 sed, 343 equals 7 qui, 256 equals 2 pairing powers. You can compare powers by calculating their values. Examples. 2 qui equals 8, 3 quad equals 9, so 3 quad is greater, 8 quatheva equals 64, 2 tev equals 256, so 2 tev is greater. 8. Basic exponent vocabulary. Term meaning. Base, the number or letter being multiplied. Exponent, or power, tells how many times to multiply the base. A cans A, cake, A cans A cans A. A b squared, A cans B has B. A can B B. 9. Important points to remember. Nias A can is positive if n is even, negative if n is odd. A b quad equals b quad a b here. A quad b put a b equal. Powers help us write repeated multiplication in short. Easy memory tips. Even exponent equals positive, minus 2 squared equals 4. Odd exponent equals negative, minus 2 equals minus 8. Order doesn't matter, powers do. Variables with the same powers equal same expression. Break numbers to primes to find power form. Would you like me to turn this into a printable revision sheet, flashcards, a mini practice quiz? Let me know. I can make your revision fun and super easy. Absolutely. Here is a clear, detailed, and super simple set of notes for you, listing concepts we learned so far, explained in the easiest words, perfect for quick revision and memory. Hack theory notes. Exponents, prime factorization, and negative bases. 1. What is a prime number? A prime number has only two factors, 1 and itself. Example, 2, 3, 5, 7, 11, 13. 2. Prime factorization. Prime factorization equals breaking a number into prime numbers only. Multiply all prime numbers to get the original number. Use exponents powers to shorten repeated multiplication. Check examples. 72 equals 2, 2, 2, 3 comes 3, 2, 3 Follinger. 2002, 5, 5, 5, 2, 5, 5. 432 equals 2, 4, 16,000 equals 2, 3. Product of powers of prime factors. Product means multiplication. You express a number using only prime factors and exponents. Hack example. 125 equals 5 times 5, 5 dio. 4. Exponents powers. An exponent tells how many times to multiply the base. Base equals the number you're multiplying. Exponent, how many times you multiply it. Examples. Minus 2 equals 2, 2 comes 2 equals 8. Minus 5 comes 5 equals 25. Minus a equal a comes a times a comes 5. Negative bases and exponents. You can raise negative numbers to powers. Rule, power type result sign, even positive, odd, negative. Examples. Minus 2 square third equals plus 4 minus 2 equals minus 8 minus 1 minus 1 equals minus 1 minus 1 minus plus 625 minus it equal NASA 1000. Tax 6. Exponent rules for minus 1. Expression result y. Even negative key equals minus 8. Minus 1 odd power stays negative. Minus 1 crowd plus 1. Even power becomes positive. 1 key on odd negative again. 1 plus 1 even positive again. 7. Ways to do prime factorization. Long division method. Keep dividing by smallest prime until you reach 1. Multiplication method. Break numbers like 1000 equals 10 comes 10 times 10. Then break 10 equals 2 comes 5. So 1000 equals 2 but 2 but 2 comes 5 times 5 is 5 equals 2 comes 5 where. 8. Important patterns to remember. 10 equals 2 is 5. 100 equals 10 comes 10 equals 2 times 5. 2 is 5 equals 2 5 times 5 squared minus 1000 equals 10 10 is 10. 2 5 by 5 demand. 9. Order of multiplication doesn't matter. 2 key can 5 gu equals 5 gu comes 2 key, same result, but powers must match to be equal. 2 quad 3 squared equals 3 squared times 2v, same. 2 quad 3, 2 comes 3 squared, not the same powers. Summary. What you should remember. Concept, key idea, viewer team. Exponent power, prime number, a number with only two factors, one in itself. Prime factorization, breaking a number into only prime numbers. Exponent power tells how many times to multiply the base. Negative base odd power gives a negative result. Negative base even power gives a positive result. -1 odd equals to -1. -1 even equals +1. Use of exponents. To write long multiplication in short, Otto's trick, 10 times 10's 10, is valid, but break 10 into primes, 2 times 5. Base and exponent. In a quar, base equals a, exponent equals 4. Nash, a memory tip. You can use the phrase, prime powers make multiplication pretty, meaning use powers to write prime factor multiplication easily. Would you like a printable version of this summary, flashcards for revision, comic strip or visual poster to help you remember? I can create all that for you. Just let me know. Absolutely. Let me now give you a perfect, clear, and deeply simplified set of notes that you can remember easily based on the concept. Multiplying powers with the same base, law of exponents. Laws of exponents, notes for easy learning. Topic, multiplying powers with the same base. 1. What is an exponent power? Exponent means repeating multiplication of the same number. Example, 2 equals 2 times 2 times 2, 8. 5 equals 5 and 5 times 5, 5, 6 and 25. A equals A times A at 2. Base and exponent. In 3 source, 3 is the base, 4 is the exponent, means multiply 3 4 times. 3. Law. When bases are same, add exponents. Rule. Am's A and equals Sam. Base must be same, add the exponent's powers. Examples. Expression. Expanded form. Final answer. Pop 2 flat. Upper kyo. 2 quadricans 2 kabao. 2 cans 2. 2 kansu korkmine. 2 fan A cum A quarter. A cum A to A cum A cum A cum A. A seth. Sve 3 kuro. 9 3, 7 times 9 3 su. 5 and 5 sec. Then 5 tuna 5 and 10 5 5 5 5 and 5 5 row. 5 quarto. 4. Important rules, theory concepts. Concept, theory explanation. Pegnative. Multiply powers with same base. Add exponents. An equals mamin. Base must be same. This law works only when base is same. Base is negative, rule still works. -2 quadricand 2 and q could equal 2. Exponent 1 is still a power. 4 equals 4 on, 5 equals 5 Base different? Don't add exponents. 2 equals 3 quad 8 9 equals 72. No addition of exponents. Caution. You cannot add exponents if bases are different. Example. 2 equals 3 quad 6 fin. 2 equals 3 quad equals 8 times 9 equals 72. Easy trick to remember. Same base, advent base, just stop. Summary table. Type of expression. Result. A quad A by. A fun, P quad times P quad, P5 minus or Q minus 3 fun, B quad times B, 2 comes 2 quad times 2 q. 2 sits, 3 times 3, 3 quad, 2 kui times 3 squad, 8 times 9, 72, no rule applied. Revision notes box, very short version. Exponent equals how many times to multiply the base. A sen times A on equals A on my sen, add exponents. Base must be same, works even for negative bases. Different bases equals no rule, solve normally. Would you like me to give you a printable revision sheet? Flashcards for memory? A quiz to test yourself? A cartoon-style summary poster? Just tell me and I'll make it for you. Absolutely. Here's a clear, simple, deeply detailed notes page for you that includes all the concepts you can derive from 11.3.2, dividing powers with same base, and tout 11.3.3, power of a power. I've written it like a personal notebook, using very simple language and logical flow, so you can understand, remember, and revise easily. Chapter Exponents, Summary Notes. Focus, Laws of Exponents, Part 2, Division and Power of a Power. Cow 1, Dividing powers with the same base. Rule, in simple words. When you divide powers with the same base, just subtract the powers. Formula, A sen or an equal is same and A psico is 0. Example, squared equals 5 seat flag equals 5 4. What you must remember, base should be same. Subtract the top exponent minus the bottom exponent. If exponents become 0, result is 1. A is equals 1 if A is 0. Do not apply this if bases are different. Example, 3 squared by 2 squared, solve normally, no rule. Useful mini-examples, expression answer. 2 king where 2 squared, 2 crew, 9 set where 9 squared, 9 foot chord, 8 where A, B where B hum, B door equals 1. Top 2, power of a power, raising a power again. Rule in simple words, when you have a power raised to another power, multiply the powers. Formula, A sin equals A nin. Example, 2 p squared 2 chi times 2 key equals 2 cis. A squared was A seat. What you must remember, multiply the outer power, inner power. Base remains same. The bracket means repeat the multiplication. Useful mini-examples. Expression, answer, answer. 3 quadricu, 3 seats. A quesu, rexu, x squared, 7 q quaid, 7 c. Theoretical concepts, this lesson. Concept description. 1. Exponent represent repeated multiplication of the same base number. 2. When dividing powers with the same base, subtract the exponents. 3. Any non-zero number raised to the power of 0 is actual 1. A stra equals 1, 4. When a power is raised to another power, multiply the exponents, 5. These rules only work when the base is the same. 6. Different bases don't apply these rules, just solve normally. Exponent matter, simplify powers before any other operations. 8. Exponents can be used with both positive and negative numbers. Our memory rhymes, very simple. Same base, subtract on divide. Power on power, multiply to survive. Power 0 makes it 1, base must stay or rules are done. Revision box, operation, what to do, example. Example, multiply same base, add exponents. 2 quit 240, 2 that. Divide same base, subtract exponents. 5 c my by 5 squared equal 5 hot. Power of power, multiply exponents. 3 0 equals 3 seats. Power 0. Result is 1 if base equals 0, 8 equals 1. Final tips to remember. Always check, is the base the same? Exponent of 0 equal always 1, except 0z which is not defined. Negative bases behave normally, but be careful with signs. Minus 2 equals plus 16, even power. Minus 2 qui equals minus 8, odd power. Practice using small numbers first. Would you like a printable PDF of these notes? A poster format? A fun practice worksheet? A quick quiz to test these rules? Let me know and I'll make it for you in the easiest form. Absolutely. Let's now make easy, clean, deeply explained notes based on the concept we just studied. Theory notes. Multiplying powers with the same exponents. Main concept. When two powers have the same exponent, same power, but different bases, we can multiply the bases and keep the same exponent. Rule. A and BA equals ABN, where A and B equals any number or variable, like 2, 5, x, y, etc. N equals exponent must be same in both. Examples, expression, use the rule, final answer, find my thing. 2 times 3 core, 2 times 3, 6p equals 216, 4 squared times 5 at 4 times 5 squared, 20 squared 400. A quarter comes B4, AB quart, xn can y fame, x and y fame, xy fame, minus 2 q can 903, minus 2 minus 3q equals 6b. 216. Why this works in simple words. If you expand both powers, minus 2 key equals 2 can comes 2, minus 3 could equals 3 comes 3, 3. So 2 key comes 3, peg equals 2 comes 3 times 2 comes 3 times 2 comes 3 equals 6 equilibrium. So you can group and simplify together. Warning, this rule works only when exponents are same. Example, 2 echelon 3 combine. Do each part separately. Organize 3 equals 27, 4 comes 27, 108. You should also know this reversible rule. A caps B Aaron and equals A on can BN. This works both ways. Trick type, simple words. Simple words, same powers, multiply the bases. Rhyme, same power, combine the base, keep the power in its place. Shortcut formula A and B it equals ABN. Reverse trick, ABN and 10BN, also useful for splitting a power. Useful for simplifying large expressions, working with algebraic expressions, writing expressions in exponential form, factoring and grouping powers, solving exponential equations. To remember, 1 4 equals 2. A quitize b equals 3. 7 to 2 equals 4. No, 5 divided minus 2 equals 5. X quitize y quadrant z zeker. Final notes to remember. No. Concept summary. Con z equals 1. A text bn equals abbn if exponent n is the same in both through 2. Multiply the bases, keep the same power. Works for numbers and variables, like xn times yn equals xyn. Watch out. Doesn't work if exponents are different. 5. ab equals an times bn also works. Signs matter. Nates a times b equals plus ab if both bases are negative. Would you like these notes as a PDF? A visual mind map version of this? A quiz to check your memory? Just tell me. I'll build it for you in the simplest and most fun way. Absolutely. Here's a complete, simple, clean, and deeply clear of all the theoretical concepts you can remember from this lesson on covering. Dividing powers with same exponents, zero exponent rule, how to express powers with same exponents, theory notes, exponents, division, and zero powers. 1. Dividing powers with the same exponent. Rule: if two numbers have the same exponent, same power, and you're dividing them, an over bn equal a word and b like are any non-zero numbers. N is a whole number like 1, 2, 3. Example: 8 whatever fourth quantity 8 4 equals 2 equals 4. A over b go equal on a over bu. 2. Expressing products with the same exponent. Rule: if you have two powers with same exponents and you're multiplying them, a and b equals a of b and multiply the bases, keep the exponent the same. Example: 3 squared and 4 squared equals 3 4 squared equals max x times y phi equals x3. Zero exponent rule. Rule: any non-zero number raised to the power 0 is always 1. Formula: star a equals 1 to where a equals 0. Examples: 2 0 equals 1 minus 5 x 5 equals 1 if x per 0 minus 1001 equals 1. Special note: 0 is not defined. We do not give it a value in mathematics. It's considered undefined. Action: additional concept recap, optional review, rule type, formula. Example: an for an, multiply with same base. An can say and a10 with sen, 2 said 2 feel 32. Divide with same base a sen by a sen mine. 5 equal 5 squared equal 5 equals 25. Power of a power, a equals to an. 3 4 b equals 3 7 equals 29. Multiply with same exponent. An times bn equals ab. 4 times 5 phi equals 20 phi equals 8,000. Divide with same exponent. An over bn, a over bn. 6 squared 2 5 squared equals 3 squared equals 9. Zero exponent, non-zero base. Age equals 1. 10 equals 1. Memory tricks. Concept, easy rhyme or tip. Same powers divide. Same powers divide the base. Keep power in place. Zero exponent rule. Any number to power 0 becomes a 1, like a hero. Multiplying same exponent, same powers, multiply the base. 0, just remember, undefined. Quick summary to memorize. 1. A and where bn equals a with b. 2. An times bn equals ab and. 3. A's equals 1 if a equals 0. 4 0 equals undefined. 5. These rules only work when exponents are same for multiply divide bases. Bases are same for adding subtracting exponents. Would you like these notes as a downloadable PDF? Flashcards to memorize? A worksheet or quiz based on this? Let me know. I'll make it for you in the easiest way possible. Absolutely. Let's now create very clear, simple, and complete notes from what you just studied so you can remember and revise easily. These notes will focus on all the concepts and rules used in the examples you asked about, Ashley. Exponent of 0, power of a power, multiplying and dividing powers, expressing numbers in exponential form, applying all exponent rules in real problems. Concepts from exponents, theory summary. Type 1 rule, 0 exponent rule. Any non-zero number raised to power 0 is always 1. Formula: minus a equals 1, 1 as long as a equals 0. Examples: 5 equals 1 minus 100g equals 1, minus 3 equals 1, x 0 equals 1 if x is not 0. But 0 is not defined, undefined. 2. Power of a power rule. When a power is raised to another power, multiply the exponents. Formula, example, a equals 8, example, 2x 2x square x seats. 3. Multiplying powers with the same base. Add the exponents when base is same and you're multiplying. Formula, a equals a, example, 3 squared times 3, 3c, minus 5 fed, come 5d equals 5 top d. 4. Dividing powers with the same base. Subtract the exponents when base is same and you're dividing. Formula, a Kempler a n equals a n. Example, 6 and 6a equals 6 minus 4 by 4 square equals 4g equals 1. 5. Multiplying powers with the same exponent. Multiply the bases and keep the exponent same. Formula, minus ab equals abn. Example, 2 gu times 3 equals 2 and 3 bu equals 6 bu. 6. Dividing powers with the same exponent. Divide the bases and keep the exponent same. Formula, a over bn equals a over bn. Example, minus 10 squared by 2 squared equals 10 over 2 squared equals 5 squared equals 25. 7. Writing numbers in exponential form. Break large numbers into repeated multiplication and write as powers. Example, 8 equals u comes 2 times 2, 8 to 8, 8, 8 times 8 equals 8 squatter. Since 8 equals 2, so 8 squared 2 squared equals 2 squared. 8. Combining rules in word problems. You can mix all these rules together to simplify problems. Examples, 3 3c and 3 get times 3 hand equals 3 times 3 get 3 and c. 2 come 2 word and 5 thing equals 2 find 5 thing. 2 we times 6 by 6 equals 6 by 6 equals 6. 2 word times 3 times 5 will 4 times 3 times 5 equals 60 equals space. Since 8 equals 2 we, 8 we 2 equals 6 times equal 2 c she. So 2 c's times 2 equal 2 fun. Memory boost, quick rules table concept. Rule, 0 exponent, 0 exponent. A z actually equals 1, a equals 0. Multiply same base. 8 cents an equals 8 my sen. Divide same base. 8 tenth of an an. Power of a power. A cent equals a cent sen. Multiply same exponent. An times bn. Divide same exponent. Divide same exponent. An wide bn equals a wide bn. Ash dash. How to remember. Chase 0 power is hero 1. Multiply same base equal add powers. Divide same base equals subtract powers. Power on a power equals multiply powers. Same exponent, multiply or divide bases. Would you like flashcards? Practice worksheet, PDF of these notes? Let me know. I'll create them for you step by step. Absolutely. Let's go line by line, word by word, and I'll explain everything in the most simple, easy, and clear way. Like you are learning this for the very first time. We are learning about the decimal number system and how to write numbers using exponents, powers of 10. Hashtag. Step 1. What is the decimal number system? Let's break it down. Decimal means based on 10. This system uses 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the system we use to count, read, and write all numbers in daily life. This is the reason it's called the base 10 system. Step 2. How does the decimal system work? In this system, each digit in a number has a place. Let's take the number 47561. Every digit here has a value depending on where it is placed. This is called place value. Let's see each digit's place. Digit, place value, name value. How we calculate. It's 1 times 1. 4 10,000s, 4 times 10,000. 7 thousands, 7 times 1,000. 5 hundreds, 5 times 100. 6 tens, 6 times 10. 1 ones of our units, 1's 1. So we can write 47561, 4 times 1,000 plus 7 times 100 plus 5 had 610 plus 1 times 1 start. This is called expanded form. Step 3. Step 3. Using powers of 10, exponents. Instead of writing 1,000, 1,000, 100, etc., again and again, we can use powers of 10. What is a power of 10? Here's a simple table. Number, power of 10 form. How it is made: 1,000, 1, 10, 0, 1 equals 10, 0. 10, 10, 10 equals 10. 100, 10 top is 10. 1,000, 10 copper. 10 times 10 times 10. 1,000, 10 quad. 10 times 10 times 10, 10 times 10. So minus 1 equals to 10 direction, minus 10 is 10, minus 100 equals 10 fwed, minus 1,000 equals 10 ku, minus 1,000 equals 10 fwar. Now go back to our example. Cat 4,705,61 equals 4 times 1,000 plus 7 times 100 plus 5 times 100 plus 6 times 10 plus 1's 1 tro. Now using exponents, toss equal 4 times 10 quarter plus 7 times 10 query plus 5 10 squared plus 6 times 10 10 plus 1 10 10 3. This is called the exponential form using base 10. Hap step 4. Try another. Let's expand 1 and 4 2 7 8. Let's first look at 10 4 2 7 8. Now break it into its place values. Digit, place name, value, plus value. 1 hundred thousands. 1 chems 1,000s. 0 10,000s. 0 times how many? 4 thousands. 4 chems 1,000. 2 hundreds. 2 times 100. 7 tens. 7 times 10. 8 ones. 8 times 1. So, 4278 equals 1 times 1,000 plus 4 times 1,000 plus 2 times 100 plus 8. Now each value with a power of 10. Minus 1,000 equals 10 to 10 minus 1,000 equals 10 forward. Minus 1,000 equals 10 ku minus 100 equals 10 squared. Minus 10 equals 10 minus 1 equals 10 jared. So, cow 10 278 equals 1 10 10 fein plus 0 tens 10 quad plus 4 10 10 ku plus 2 tens 10 quad plus 7 10 10 plus 8 10 10 the record. Even though 0 10 10 square equals 0, we still write it to show the position. Next, step 5, pattern of exponents. If you look carefully, in both 47561 and 14278, the powers of 10 start from the highest digits place by 1. They add 10 zen which is 1. This is very important in decimal system. Each digit's position equals power of 10. From left to right, exponents go 10, 10 forward, 10 squared, 10 fun, 10 ger. Final simple notes to remember. Decimal system equals base 10. We use place value and powers of 10. Place values with powers. Place, power of 10, units. Units, 1s, 10 zu, tens, 10 fen, hundreds, 10 quadrad. Thousands, 10 crew, 10,000s, 10 core, lakhs, 10 theme, crores, 10 say. To expand a number, multiply each digit with its power of 10. Start from the left with the highest power. Go down to 10 zeros at the last digit. Example, 47561 equals 4 times 10 forward plus 7 times 10 qui plus 5 times 10 querded plus 6 times 10 rin plus 1 tenzi. Would you like a practice worksheet or fun comic version of this? I can also help you try your own numbers step by step. Just tell me. Absolutely. Here's a clean, clear, and complete theory notes page for you, based on the concept of expressing large numbers in standard form. I've broken it into simple bullet points with explanations so that it becomes easy to read, remember, and revise later. Notes: expressing large numbers in standard form. Mashrakan member 1. Need for standard form. Large numbers like 300,000 ausings are hard to read, write, or say. Standard form helps us write such numbers in a short, clear, and easy way. 2. Definition of standard form. Standard form is a way to write large or small numbers using powers of 10. It is written as A10, where A is a number between 1 and 10, N is a whole number. 10 hen and ma means 10 is multiplied n times. 3. What are powers of 10? Exponents. Exponent, value, words, n. 10 grid, 1. 1, 10 hen, 10, 10. 10th word, 100, 100. 10 ku, 1,000, 1,000. 10 score, 10,000, 10,000. 10 fei, 100,000, 1 lakh. 10 sex, 1,000,000. 10 lakh, 1 million. 10, 1,000,000. 1 billion. 10 wa forsterboid. Ones in thousand, 1 trillion. 1 trillion. 4. Steps to convert a large number into standard form. Step-by-step rule. 1. Move the decimal point to make the number between 1 and 10. 2. Count how many places the decimal moved 3. Write. New number, kex 10 square number of places. 5. Examples. Original number, standard form, 5,900. 5.9 times 10 q, 56,439. 5.6439 times 10 for 2. 172. 1.72 times 10 quid. 5,976,000. 5.976 has 10 quarters quart, 100,000 10. 110 300,000 halvend built. 3 comes 10 quartilifgeld. Asherkosh. 6. Important concept, decimal point movement. Every time you move the decimal point left, the exponent of 10 goes up. You move until the number becomes between 1 and 10. Example, 980,000. Move decimal from n to after 9.8. You moved SAR 5 places. So 980,000 equals 9.8 comes 10. 7. Why use standard form? Advantages. Saves space and time. Helps in scientific work, astronomy, chemistry, physics. Makes calculation easier using exponent rules. Useful for comparing large numbers. 8. Standard form versus normal form. Normal form. Standard form. 1,000,000. 1 kens 10 sex. 45,000. 4.5 times 10 squared. 5,605.643 times 10. 9. Visual shortcut. Count how many digits are the first digit. That's the power of 10. 1,000,001, followed by 6 zeros, 10 sex. So, 1 10 sesisht. Final revision tip. Remember the pattern. Move decimal count steps, multiply by 10 heaven. Example, 456,000 equals 4.56 times 10 sixth free. We move decimal 6 places. Would you like me to also make these notes in PDF form or comic strip mind map style for even easier memory?